Michael and Torsten and a bunch of our customers. So thank you once again for coming out. I just want to start off really quickly. How many of you in the audience are IT implementation folk who are working on applications, either launching them in cloud or running them in cloud? Show of hands. Excellent, great. And how many of you would say, either you may also be decision makers, but I'm curious, how many of you are kind of the folks still defining your IT strategy and how cloud kind of fits into that strategy? All right, wonderful, thank you. So we've got a good agenda for you here today. What I'm going to try and do is, first of all, talk a little bit about what RightScale offers and what we see from RightScale's perspective around SaaS in infrastructure as a service. RightScale, again, being that layer above infrastructure as a service. And then from there, I want to introduce one of our customers, Chris from the Resumator, who's going to be talking a little bit about what he's doing on cloud and how he's leveraging cloud to enable his business to be very successful. So we'll talk about all of that today. I skipped the intro slide really quickly, but in case we haven't met before, my name is Shivan Bindal. I'm a product manager here at RightScale. I've been with the company for a little over 2 years now, and I manage a wide variety of things within the platform. Specifically here, what I'm trying to talk about is the capabilities that RightScale offers, and as well as the capabilities our customers use and how they're applicable to running SaaS-based applications at scale using infrastructure as a service. So to start with, I'd like to just do a basic review of some of the capabilities RightScale has to offer, and I fully intend for this to be rudimentary, and I hope we can get through this really quickly. One of the key things that RightScale has to offer is this abstraction from instances of these raw compute-based instances that exist in infrastructure as a service, and we do that with our technology called server templates. Server templates allow you to set up cloud resources, particularly compute resources, dynamically at boot time. And so there's a lot of configuration management that you can build into these server templates that enable you to do things on cloud in a consistent, reliable, and repeatable fashion. And with that, you get a lot of the capabilities beyond simple provisioning that RightScale has to offer, things like monitoring. And from monitoring, you get alerting and notifications. Beyond that, you have the ability to take an operated environment, an environment that's already running in cloud, and do things on top of it with runtime configuration, running an operational script, taking action, and controlling your infrastructure. And what that really enables you to do is transform your IT workflow into more of a dev-like workflow, ultimately getting you closer and closer to what others in the cloud world are really calling the holy grail of cloud adoption, which includes DevOps. And then what these servers from these server templates end up being contained within, or whatever you might consider a contextual container in cloud, RightScale represents that with deployments. And we found deployments to be very useful to our customers because they give you a bit of abstraction higher and above the raw resources available in infrastructure as a service today. It allows you to abstract the components, I've listed a few here, virtual machines, the storage components, virtual networking, and whatnot, and it gives you the ability to organize these things in a way that will make sense. And we'll talk a little bit about what that can look like in specific examples from either RightScale as a consumer of our own platform, as well as from some of our customers, and of course you'll hear that from Chris later today as well. And the idea, though, that I want to convey about this container within RightScale is that ultimately this container represents something. And that something is important to your business. It could be something as simple as a customer. It could be as complex as an entire environment. And ultimately, having this container with that stuff in it gives you some capabilities that we can talk about in a few minutes. Things like, very briefly, cloning and relaunching and being able to do things in a very highly efficient, automated fashion. And these are some of the capabilities that we've learned our customers really value when they're looking at applications on cloud. And the third thing that I want to talk about is our user model. In particular, we find all sorts of customers coming to RightScale and trying to use infrastructure as a service. And depending on which cloud provider you might be using, there are a variety of capabilities that these cloud providers offer. And some are more mature, some are less mature. Ultimately, they'll end up in some same, holy grail state somewhere down the line. But today, the offerings might be somewhat disjoint. And what RightScale provides from a user perspective is we give that single pane of glass over to our users and to our customers where their organization can really adopt cloud in a way that makes sense for them. And so an IT organization at a company or a group of developers within a business can leverage cloud computing in the ways that make sense for them. So every single one of them would have access to the platform, and every single one of them can use the same cloud resources within the same cloud provider in a seamless and oriented way, while at the same time the organization can do things like permissioning that provide capabilities to each of their users. And at the same time, within that, these things are related to that organization, to that business. So I, as a developer, and my colleagues as a developer can now be organized within the RightScale environment as an account, as a business, as something that's concrete. And what RightScale then can do for that organization is provide a lot of visibility, because we have this container again of isolation, an environment in which you can actually do something. Some of the capabilities that I've listed here may resonate with you. I don't want to go through this in very much detail again. I wanted to provide a very high-level overview of what we have to offer. But we found a lot of our customers leverage these very simple capabilities within RightScale as part of how they get to cloud and how they run at scale on cloud. But let's go a little bit deeper now. So we talked about the high-level functionality. What does that translate to within an organization? And how do you apply contextual awareness in infrastructure as a service so that your applications can really make sense for you on cloud? With specific regards to deployments, this is a traditional use case that we see time and time again with our customers. Each of these yellow boxes represents a deployment. And within a deployment, you have, again, the deployment being a container, you have a variety of different compute resources. And, in the developer sandbox environment, you might kind of have very simple architectures where developers can easily spin up servers that they can use for development, for testing, and whatnot. Whereas as you progress through your software development lifecycle, you start to move into a staging environment where you're taking the application code that your developers are doing and building, moving that into a staging environment where your QA resources can now integrate and do a lot more regression-oriented testing as well as functional testing against the application as a whole. And then finally, as you start to find stability with your application in your staging environment, you progress that into a more robust, well-architected, highly scalable architecture in your production deployment. And all of this is a traditional use case that we see with our customers. In specific example, I hope some of you know, if not all of you know, that RightScale actually dog foods RightScale. We manage and run and operate at scale using RightScale. So the RightScale platform itself runs on RightScale. You may have heard Torsten allude to this morning where, just last month I think he tallied our servers and we're at, I think, 1,800 servers running on cloud right now for our platform. So that gives you a sense of the scale at which RightScale itself operates. And in terms of how we leverage our platform to run our SaaS-based application on infrastructure as a service, we are absolutely using contextual awareness. Every employee at RightScale has an account, has a user that can log into RightScale and get access to cloud environments. And in specific instances, we have those developer sandboxes where each developer can use what we call them test accounts, obviously, but they can create deployments and servers as they are needed in order to do their job, in order to do the development work that we need them to do so we can ship product. And then we have an organization just, completely side by side that is working with them on building functional testing and regression testing. And they operate this testing in the staging environments, the staging deployments. Again, these containers that represent our integrated functionality spread across the tens of teams that we have in development, bringing all of that code into our staging environment and running all of our regression and functional testing. And then finally, once we find stability within our staging environments, our operations team has the ability to take that code base with certainty and move it into our production environment. And our production environment is actually not necessarily accessible by our development team or our QA team. We have a separation of roles included as well. And we can dig in deeper here, but again, want to get into a very high-level discussion of what does it take to run SaaS on infrastructure as a service at a high level. Well, it takes the ability for your entire development and operations team, including QA, to be involved in a very joined effort to deliver software. And part and parcel to that is our development team, in terms of cycle and communication, is working on services that our operations team is engaged with day one. Because the way we deploy our services down here at the bottom in our separate environment for production is completely aligned with how our developers are developing applications, how they're launching them in these deployments and servers up at the top, in terms of being able to do their unit testing and the functional testing that we're doing in our staging account, right? So these groups, these sets of teams are all very much so working together to get SaaS running on infrastructure as a service. We also see a lot of non-traditional use cases, and when I say non-traditional, I mean, we see a handful of these. Sometimes this is more of a path towards the traditional use cases. In some cases, this is the status quo for some time. But, and I want to get to this in a moment, what we sometimes see with our customers is that they're on the path towards cloud adoption. They're building out their IT strategy. I know a number of you may be thinking about something similar. And when it comes to cloud adoption, they realize to get started first, to get going, they need to take what they have today and get that running on cloud. And to some of our customers, what that looks like is taking a legacy on-prem, single-tenant application workload and moving that into cloud and launching it per customer. And so the contextual awareness that they need is to understand, what does a customer mean to me on infrastructure as a service? I know that I had to launch my application for customer X and launch another instance of my application for customer Y. How do I know which resources apply to which customer? And in this situation, they use our deployment capability, our container capability, to represent what to them, at their business level, is a customer. And buzzwords, go ahead and criticize me if you will, but SaaSification-ism, that's a new one for you. I was trying to keep it light. It is a Friday morning. But once on-prem legacy applications, they can be brought to cloud in some instances. And what we found with our customers is that they want to take the applications that they already have, the workloads that they know will run on cloud, and start to work with them, because again, they're defining their IT strategy, of which cloud is a component. Their cloud adoption is a component. And so they want to go through something that is well known to them before they kind of just start off in a greenfield environment. This is some cases. I did mention before this is a non-traditional use case, but we do see some of this. And it's important for you to recognize that there is flexibility in terms of how you can approach building applications on cloud. In some cases, you might wonder, well, I'm kind of taking the single-tenant application, and when I sell it traditionally outside of cloud, I have a whole full package around what I'm selling. I sell services, I sell support, I sell installation. I have a PS team that goes on site to these customers and installs my application on-premise in their data centers. And in cloud, I no longer have the ability to charge for those types of services. And so you might wonder, well, I'm launching all of this stuff for every single customer, and it's all single tenant and represented very cleanly, but it may be expensive. What we found with our customers is that cost to them is irrelevant because of a few reasons. One, the value of being able to provision these environments and deliver them to customers in a much faster, much more automated fashion is really powerful. From a sales cycle, from a sales engagement perspective, you sign a PO and 24 hours later you have the environment to deliver to the customer. That's powerful. You don't have to wait for bodies to land on the ground and do a whole cycle of installation, testing, validation, and acceptance, right? And so from one perspective, you can think of value in that way. And two, pricing strategies are, there's so much research being done right now on pricing strategies for applications in cloud being delivered as a SaaS model, right? So you can consider building in your actual real-time costs into your pricing strategy, because as you move your once legacy on-prem applications into infrastructure as a service and start delivering it with, in the paradigm of software as a service, your whole business model, including billing, will change. And so you just need to adapt to your cost structure. At the same time, this does require a little bit of ingenuity from an operational management perspective. If you think about the level of scale you're operating at, in the previous environment, somewhat simplistically, I represented only one production container. Well, now, if I go back one slide, each one of these containers represents a production environment. And so you have to consider what are the tools that I will need in order to do code updates, application updates. What if I need to take all of these application servers across all of my customers, or maybe for individual sets of customers? How do I upgrade application code? How do I give them new features? How do I give them the capabilities that drive value for them to stay on my platform, right? So there are some concerns that come about when you think about how you SaaSify existing legacy on-prem applications. But we found that there are solutions to this, and we can talk about individual instances in a moment. Specifically, I wanted to now kind of transition into, from the high-level container of what a SaaS application may look like in cloud, in infrastructure as a service, and dig into the details. And if I can leave you with one thought today, I want you to understand that, look, complexity exists in cloud, but where should it exist versus where do you want it, where will it exist? If you think about your application, your workload, your business dynamic, that's where the complexity should be for your organization. And the management of that, the representation of this SaaS application in an infrastructure as a service can be quite simple relatively. And that's what I want to leave you with, that keep the complexity of your workload in your application. Don't push it up into the stacks of, how am I orchestrating this stuff? Where are the pieces and how does this all look? And how do I do stuff with my application in cloud? These are some of the diagrams, and I'm going to run through a few of these. This is one of the diagrams that our professional services team put together for one of our clients. And what I wanted to represent when we walk through some of these deployments is, don't worry so much about what specifically is happening. This is complexity, but this is the application itself being complex. If you think about it from the container perspective we just talked about, this would be a deployment, right? A representation of what the application and the workload is. In this specific example, we're talking about a video distribution service that a customer of ours was building. They have video in object storage. In this particular case, this was a rack space engagement that we did. And so they're using cloud files as their back-end storage. And they're running CDN and video codec transcoding out of Windows Server environments out and then through a load balancing tier being delivered to their customers, to their users. And then over on the right side, they're doing a lot of their web application stuff, things like search with Solar on Linux with Apache, right? And what's not represented here that's also built into this infrastructure is a mobile application that allows them to surface this content on mobile devices, right? So that right there is the workload, and that's where the complexity is. All of these boxes represent something very tangible to the business, right? But from a management perspective, from the perspective of how do I get this application on cloud, let's pull that complexity down and keep it in the application itself rather than pulling it up into the pieces in which we run SaaS applications on infrastructure as a service. So this is one example. Another example I have here is a customer of ours who was somewhat sensitive. They had they were a trading platform. And so because of compliance reasons and security reasons, they had to run their actual application, their trading platform, in their own data center. And so that's what's represented below the line here. Up here at the top, kind of in the middle here, that's where what they were running on infrastructure as a service. This is what they're running in cloud. And in this specific example, what we have is a customer running clients that interfaced back with their trading platform that was running in their data centers. They were using VDI, virtual desktop infrastructure, using XenApp from Citrix, and so they had built out, or we had worked with them to build out a scaling array of XenApp clients. I think they were at a density of, let me get this right, I believe it was 8 clients per XenApp node, and so they were able to scale out very efficiently, very effectively. They were using pretty much an entirely Windows-based stack. They were running Active Directory within their cloud-based environment in order to authenticate the clients back to their on-premise sort of platform. And so again here, when we think about SaaS in infrastructure as a service, there's complexity here. In fact, we can dig in a little bit deeper and recognize this looks like an Amazon deployment because they're running VPC networking on their cloud environment and cloud infrastructure, and very rightly so because, again, as we talked about, they have some security and compliance concerns because this is a trading platform. They have their application really running in their back-end data center. Right? And so they have to be able to control and restrict network traffic, both ingress and egress, and they're able to do that efficiently with this cloud environment. But again, that represents more complexity, right? They've got more networking constructs and capabilities that they need to be able to hone and use effectively as part of their overall application. Great. And the last one I want to talk about is more of a hybrid scenario. You may have heard from other customers this past couple of days about hybrid infrastructure and organizations of that nature. In this particular case, we're talking about a customer who wanted very low latencies between their 2 cloud environments. And so what they did was they placed their private cloud environment very close to Amazon again in this case. And this is why. With Amazon, you have the capability of using Direct Connect, where you can create very low latency network connectivity between Amazon and another data center. And so that's what they were doing here. They have basically some web applications that they're trying to optimize from a cost perspective, bringing it in-house. And again, though, they're talking about cloud bursting in a very unique way because the application that they're launching is truly multi-cloud in this situation. It's the same app across both cloud environments, right? So now think about complexity. We've talked about infrastructure as a service. Every time you think about like a SaaS-based application in infrastructure as a service, 9 out of 10 times a customer is thinking a single Amazon region or a single cloud provider in a single geographic region. Here, these guys are breaking the mold, right? They're taking two separate cloud environments and taking the same application and running it across both. Now you're talking about a SaaS-based application that's fault-tolerant, HA, right? Assume for a moment that this private cloud wasn't very close to the same geographic region as this guy, and you can now think about natural disaster-proof or business continuity solutions as part of this. Right? Those things are extremely valuable from a business perspective, from the orientation of how does my application work for my business, for my consumers, and whatnot. And again, the complexity here is really driven down to the application itself, right? The application itself needs to know which environment am I running in? How is my data being presented to me? Is the application in which area and whatnot? How is my network connectivity being affected? Are my user requests, do I have sticky sessions across my load balancing tiers across these two environments? And how am I doing session management across the divide, really, if you think about it? So again, I want you to think about, where's complexity? Where do I want to spend my time when I think about SaaS applications and building for the cloud or operating in the cloud? Keep things as simple as possible where you can, because your application will be naturally very complex. And so with that, I want to invite Chris from the Resumator up and have him walk through some of the things that he is, as Director of Engineering over at the Resumator, has gone through in building out their application. Chris?
Thanks. Thanks, Shivan. Good morning, everybody. What I want to do today is just walk you through some of the challenges that we've had at the Resumator as we've grown and scaled our SaaS-based business. So I am the Director of Engineering, as Shivan said. We've confronted a number of challenges over the last year or more. So let me just start off by explaining what the Resumator is. It's a SaaS platform for collecting resumes and managing the hiring process. That's at a very high level what we do. There's some complexity with the product that presents some unique technical challenges with it. So I'm going to give you just a quick product tour, just run through some of our core features. So we allow people to build custom career sites. You can get into our application and customize HTML, CSS, add some proprietary markup language, and build a career site that matches your needs. Here you can see a customized page that one of our actual customers used. There's no branding from us. It's totally white labelable. And we also allow you to process documents and render documents in the browser. So you can see an example of a resume here that's processed, rendered, and displays exactly the way the applicant intended it to in a client's application here. We also have a pretty advanced, robust search capabilities. So you can search through resumes and applicants and candidates based on any number of filters. So here's somebody who took an embedded C test. They have a specific answer that we're looking for. They may have needed to have 4 stars, been in a certain geographic area. You can filter down on candidates using that. We also allow email messaging, which you see here. And there's a few other features as well. But you can see that each one of those features has a very unique technical challenge behind it. And I'm going to discuss a little bit more in detail one of those features specifically, discuss exactly how we ran into some really big bottlenecks with it, and then how we overcame them as well. First, let me just give you a little bit more background on the company so you can understand the context and where I'm coming from. So in 2009, the Resumator was founded in Pittsburgh, PA. Very young company, very small company still. Just one employee was the founder of the company. He was a graphic designer by trade and kind of crossed over into the software stack. He actually wrote some of the initial code and did a lot of just the basic building of the business. Just one server, one employee, very simple. And you can see here that 2011, the business was still going strong. The growth, it was substantial. It was moving upwards, but the company wasn't huge. So in 2011, the Resumator was fortunate enough to have a Series A round of funding. And from there, you can see the growth here kind of kicked up a little bit around mid-2011. But from an engineering standpoint, the company only added its second engineer at the end of 2011. So the company had basically ran for 2 years with just one engineer. Right around this time, the Resumator also made the move over to AWS and to RightScale. So let me show you 2012, because that's when things kind of got interesting. So we had the Obama and Romney campaign actually come on and use the Resumator platform as customers. So they used our platform to hire all their candidates during the campaign season. And you can imagine there was media attention with that. There was press, and there were a lot of people just looking for these campaign jobs. So we saw, a pretty interesting traffic spike there in early 2012 that paralleled not just them, there were a bunch of other customers. And like I talked about too, with these custom job boards that we offer where you can kind of customize your career site, we're actually serving two different kinds of customers. So we have on one hand, the people that are paying us, that's the actual company that's trying to hire. At the same time, the scale can be impacted by the popularity of that company, because if you're an extremely popular company, you have tons of applicants coming to your job boards. We're facing a whole other wave of traffic who just wants to apply for a job. They don't really care that it's the Resumator or anybody else behind the scenes. So with somebody like an Obama campaign, this is in the media, everybody wants to work there, lots of traffic. Then things got even more interesting as we had a Series B round. One of our investors was Salesforce.com, which was an awesome validation of the business, I think. We saw a lot more large customers starting to uptick, and this is getting into late 2012 here. We were still only at 3 or 4 engineers, 1 systems administrator at that time, so still a very small, scrappy company, and I think we were very proud of what we did without having a ton of people on board, but we did see this kind of crazy growth curve this is really just happening from last fall up till today, where we saw over 1.1 million resumes processed through our system. We just saw an incredible burst of traffic, and we were able to scale our engineering team strategically to meet some of those demands. So what comes next after you see some kind of curve like that? If you're a successful startup and you're fortunate enough to be able to see that, it can be a little scary because you never know what's around the corner the next day. You want to see that curve continue to move up, but you have to be prepared too. So at the Resumator specifically, we wanted to minimize the amount of unknowns, staying a step ahead of our growth. So what we did is we've benchmarked some trigger points for scaling. And to my last point on this slide here, you want to iterate on your architecture, not perfect it. So we use services like New Relic, which is a monitoring service, as well as other monitoring services where we can actually benchmark and determine how our application is performing and kind of where we want to see it going. So if we don't see the performance increasing or we see it getting worse, we know that there may be some certain trigger points for scale. And also on that last point, if you're coming from a small team or a small startup, you don't always have unlimited funds and resources to throw at a problem, so you sometimes have to make do with what you have. You can't always say that we're going to have the perfect architecture or that our architecture is going to be 100%. We don't claim that at all today, and we've been around for basically 3.5, 4 years. We don't perfect it, but we make sure that our architecture can iterate and scale as needed, and we stay a step ahead of that growth curve. Let me talk a little bit more about our team, just really briefly. We have 7 engineers, like I said. We're all somewhat of generalists. I think everybody's very, very good at what they do, but we don't have people that are necessarily specialists in one area. We have a lot of people that can jump across the stack into different areas, and that really helped us as an early stage startup. If your company is not a startup or it's a larger, well-established company, there's still some general principles there for small development teams, where having these kind of generalist roles that can jump between systems and engineering, you have your engineers really seeing the full spectrum of the product, which is great. And just a couple other points about our team here. Continuous deployment and just code deployment in general is a topic that a lot of people I know are interested in and have discussed at this conference as well. And I'll talk a little bit about that in a second. I just want to give you a quick overview of our tech stack. We're EC2, S3, LAMP, Varnish, Redis, Apache Solr. Nothing there that's too crazy or uncommon. I'll show you a little bit of what our architecture looks like here, just at a high level. It's pretty straightforward for a SaaS product. There's nothing here that's like out of the ordinary or mind-blowing. We have a load balancing tier. We have an app tier. And as you saw earlier with Shivan's, some of his diagrams, a lot of people are using the auto-scaling functionality in RightScale. So as we see traffic come onto our servers, we can actually scale the app tier up and down as we need to. And that's where you see the 1 to n right there. On the data tier, it's a simple master-slave replication architecture, very common in databases. We also can do other things in RightScale, like having another slave just for reporting. You can do some different types of workarounds like that as you need with just having the master-slave paradigm there. And then also, you can do some type of offsite replication or backup or recovery region. Shivan also touched a little bit on that. For us, we are primarily based on the US East region in Amazon Web Services, which has been known from time to time to go down, which some of you may have experienced. Because of that, it's good to have a backup plan in place. I'm not going to dive into the recovery plans. I know a lot of other talks here are touching on that, but keep in mind that through RightScale, you can always have that disaster recovery plan. You can have a passive region ready to go, and you can replicate your data out. Also for us, we have some ancillary services like a queuing service, Solar, API, common things you'd see in a SaaS application. Here are our actual instances in RightScale. So we have a production instance. That's obviously the environment that has to be working all day, all night. If it's not working, you're going to get a call or an alert at any time of the day or night. We have a number of other environments that are similar to production, and they also have their own unique characteristics. So our staging environment, very similar to what actually Shivan showed earlier, our staging environment is a direct replica of our production environment. So we know that if you're testing code on staging, you're going to get the exact same performance. You're not going to see the customer traffic, so you may not be able to test quite at scale, but we do have sanitized data and copies of data that you can test off of. So you know that staging is going to be very similar to production. We have other environments like an API, a testing environment, a West Coast environment, reporting. And the great thing about RightScale are through deployments, you can customize and tweak those as needed, and you don't have to be super technical to even do it. As long as you have a basic understanding of what you're putting into these deployment regions, you can have a lot of your team contributing across the stack there. So let me talk a little bit about how we actually develop and deploy. So this is us, we have a SaaS application, we're taking it to the cloud. And like I said, we're not doing anything that's incredibly crazy or difficult to do. It's just a matter of putting the pieces together. So all the way down to a requirements level, let's just say there's an issue. In this case, we're using the software Jira. We have an issue. We commit code. We can link the code to that issue. So we know that all our code being committed links to that issue. And then what we do as the code kind of piles up and it becomes ready to go, you can tag a release. In this case, we can use a write script to simply check out Git code onto our application servers. So there's all sorts of different ways you can deploy code, whether it's Capistrano or whether it's using a much more robust deployment, like continuous deployment service like Jenkins, which a lot of people do use. But there's other ways to do it without going and really working with a whole different service. So for example, here we can have a write script that just checks out code from our GitHub repository. What we can do is we can say, okay, check out this release, this tagged release into our testing environment. In our testing environment, let's kick off a series of tests. Let's log the test results. And hey, if the tests don't pass, you don't want to continue, right? You want to tell people that the test failed. So in this case, you can check the tagged release out to deployment, whatever that deployment is, whether it's staging, development, or so on. So this is a really easy way that we've been able to kind of use RightScale to do continuous deployment. It's a light version of it, but it gets the needs done for us based on working in a small development team and a team that really values iterating and working quickly. Let me give you a little bit more concrete example of a problem that we faced. So we saw a lot of routine activities bringing our systems to a standstill. Not to pull back to that graph, but when the curve is looking like that, you better start looking for bottlenecks and problems, because if you don't, you're going to find out very soon. So in this case, document processing and rendering. So we collect these documents and these resumes. Like I said, there were 1.1 million just during that growth curve. And so it can be kind of interesting to see what we have to do with these documents. So these are some of the requirements that we have when we take in a document. So a job seeker submits a resume. It could be in a number of different formats. We actually convert everything into a PDF, so it's easier for us to render and display. We extract text out of that document. So you can imagine that at each one of these steps, there's a specific technical challenge that we had to solve or somebody had to solve. We store it on S3. We display it in the browser for the customer to review. So if you can't get to this point, you can't see the resume in its original format, and you can't be able to search the keywords, we failed. We have to make sure that you can actually grab data and understand what is actually in that document and being able to actually search on it. So here's the old way we did it. We stored the file on S3. We added a record in a MySQL database. We ran a cron job. Basically, we had a magic number, -4. Could have been anything, but that's what we picked. And if it said -4, then you would try to send it to a third-party service. And if the third-party service could get text, they sent it back. If they couldn't, there was some sort of failure. there was some sort of webhook callback. And that was all happening as soon as you applied. So this didn't scale at all. We had a lot of problems with this. So we came up with, we kicked around a few different solutions. In this case, this is a pretty textbook example for having some sort of queuing service where you put jobs into a queue. When they get to the end of the queue, you process the job. In this case, this isn't real-time data. You don't need to have the resume available that instant, that second. This isn't like Twitter or something like that. As long as we are able to grab the resume, process it, grab the data, and do it in a meaningful amount of time, or a pretty meaningful amount of time, it's acceptable to the end customer. So we designed a simple queuing system. Our kind of idea was, let's just be able to send an arbitrary job to this queue, and then, hey, we'll let the software team figure out what they do with the arbitrary job. But in our case, the software guys were also the systems guys for the most part, so they had to figure it out there, and that's where you see that kind of small team, very interconnected, people that wear multiple hats. That's where you see a lot of benefits. This wasn't somebody coming up with a spec and then somebody else implementing it. It was the people that were speccing it and understanding the problem. They were all ingrained with the solution from end to end. So actually developing this, there's a lot of research, there's a lot of thinking that goes into it. So we experimented with different queuing services. A couple of them are listed up there. We ended up using Redis, simple, fast, free, and really getting back to, the specifics here probably won't apply to you, but the general principles will. And the fact is, with something like RightScale, you can get that up and running in just a matter of minutes. Now, obviously, researching and testing is still going to take weeks. That's not figured out. You're still going to have people doing that. That's not going to be easy to do. It's not simple. But let me just show you how our queue actually looks from a write script perspective. So getting back to Shivan's talk, we talked about these containers. These containers have a number of scripts in them. So here you can see some of the scripts that we use in actually launching this queuing service. And now the nice thing is the queue can be spun up into any of our development environments, any of these you want to. So if we wanted to say, hey, we need to add the queue into our staging or our test environment or our West environment, we can do that just as a simple, literal click of a button. So a lot of work goes on behind the scenes. There's a lot of software complexity there. But at a systems level, a lot of that complexity is removed here through RightScale. And like I said, you're able to spin this up into any deployment or even make a new deployment that has it in it. So for our initial rollout, we saw 30,000 jobs being processed per day. We saw incredible end user and app server performance improvements. We've expanded the queue to take 4 different types of jobs, but that number is arbitrary. As we have time or the need to implement new things, we can simply add them into this back-end service, and it's already a piece of our architecture. And the thing here is, without making any sort of drastic changes to our infrastructure, we're able to handle traffic growth. Now, this wasn't the only thing that we changed and we've improved on. For us, it's always looking at what's that next thing. So at one point, it was caching. At one point, it was Apache Solr. At one point, it was queuing, and that's the example I gave you here. But the bottom line is, you don't have to rip out your infrastructure. Hopefully, assuming you're moving iteratively forward, you don't have to rip everything out just because you see different patterns of use in your SaaS application. So just a couple lessons as I wrap up here. Set triggers for scaling. That's what I mentioned earlier on, where we have different monitoring services. You have to know what's going on in your application. It seems like common sense, but if you're waiting till the last minute to scale, you're going to be in trouble. Iterate on your infrastructure. Don't lock it in. I would love to stand up here and say that we have the perfect infrastructure, but you know what? We're a 7-engineer startup. We have real funds from real investors, and we have to take that money seriously. We don't have the luxury of just throwing capital or people at the problem, making it go away. You have to make do with what you have, and you have to kind of do more with less sometimes, especially in SaaS-based startups, where you see these end users using your application. They can happen in any. It's unpredictable to know what's going to happen in traffic. Small teams greatly benefit from generalists. This may seem like common sense, but if you specialize too early, if we would have said, hey, we're going to build the perfect architecture out, and then we'll worry about the product, that's the problem right there. You wouldn't have had a compelling product. So for us, it was building a great product while we were iterating on the system side. And then here, knowing when to shed old technology. MySQL is great for what it is, but there are times when you don't want to use MySQL. It's that simple. And you'll find that with pretty much any technology out there. So having the debate, is MySQL, should you use it, shouldn't you use it, it's really irrelevant. You should use it when you need to use it, and when you need to shed it, you should have already set your triggers for scaling. You should already know that, hey, we could use Redis or we could use Apache Solr, and we could actually help MySQL by not having it do things that it's not the best at. That's pretty much all I have to wrap up. So I hope that you guys can take some of these lessons, apply them to your development teams, your IT teams, your startup if you have one. And for any type of SaaS company or small team, I really think that there's just some general applicable lessons, and hopefully you can take some of these away. I think Shivan has a couple more, so I'll switch back to him. Yeah.
You can just stay up here too. Just a couple things that I wanted to wrap up with. I think now you've gotten a sense of kind of the things that RightScale sees, as well as what some of our customers have experienced. And ultimately, when you're thinking about your IT strategy, I think a huge component about IT strategy itself is recognizing where cloud is valuable. And from our perspective, of course, at RightScale, right, cloud is the way to deliver software to customers going forward. And so an IT strategy, in our minds, cannot be complete without accounting for and including and incorporating some part of cloud in there. But ultimately, the complexity of that environment is and will remain in your app. Over time, you can extend that complexity if you so choose, but we strongly recommend trying to contain the complexity within your application. Most of the successful environments we've seen have been in situations where the application is really where most of our customers spend their time and their focus. We talked a little bit also about some flexibility, how you can use certain things, even at a very basic fundamental level, in order to ease your adoption to cloud or ultimately just keep your business going and be successful with your IT strategy. So keep that in mind, that there's no one set course. What one person tells you doesn't necessarily have to be the way that you go in terms of your cloud adoption, how you can be successful on cloud. And ultimately, there are a variety of experiences. Hopefully, in the last few days, you've encountered some people who have been successful on cloud with or without RightScale, and you can take those examples and those experiences back and apply them in your situation. So with that, we've got a few minutes for questions. I wanted to open it up and let you guys pepper us with questions now that you've listened to us for about 40 minutes. Any questions from you guys? Sure.
So for Chris,
sorry, one second. Get the mic.
Chris,
Yeah.
so for your software as a service, you don't have, it didn't look to me like you have, he presented kind of this situation where you might have multiple tenants in multiple deployments, isolated into each deployment, and kind of put forward the idea, hey, spend the cost to do that because ease of duplication is going to pay it back. I didn't notice anything like that. Do you guys have a concept of multi-tenancy, or are your clients, your companies, are you dividing that up just at the database level by just identifying this is for this account? Yeah,
that's a good question. So for us right now, it's just one production deployment, which, like I said, we deploy that in the East region on AWS. For us, it gets a little bit back to some of those scaling triggers. We do have a pretty aggressive systems roadmap, and we have those points in place where we may have some sort of live region that's in a different area, whether it's on a different provider or whether it's just simply in a different geographic region. Right now, no, we have one production deployment, but I see how, the point that you're making there.
Do you charge your clients by usage at all, and how do you get metrics out from your infrastructure to know what to charge what client? Like, say you have one huge client who's Mitt Romney, and he's using this service, and 90% of your traffic is Mitt Romney. How do you know to charge him 90% of the bill, or how does that work?
Yeah, it's tricky. I mean, and that's kind of the challenge with SaaS, is just developing pricing that works. So we have to have pricing that works from somebody who just wants to post, one job and collect a couple resumes to fill one position, all the way up to the guys that want to, hire 1,000 people or more. We actually just have a tiered pricing structure. So yeah, you are going to kind of take a loss on some of those, and you go down the spectrum. So we go all the way from free for from people that just want to use one job all the way up to people that want to have 500,000 jobs, and they have a pricing range based on the number of jobs that they're using. So we kind of scale our pricing based on how many jobs you have open in our system. We don't base it on usage, so to speak, and that's where you do see a lot of challenges because, yeah, if somebody's paying you, they only have, say, 50 open jobs, and they're paying you a certain amount of money, and they have a ton of people using the system, you are by nature going to be experiencing a lot more higher traffic volume from them. But we don't bill them on that. So it's a lot of it's just getting back into the strategy of how do you structure your SaaS business from a billing standpoint, I think, so that you're not getting burned by people that are really extremely high users. Anything else?
I have one other question, just about your staging environment.
Yeah.
Did you come to a decision of saying we're going to put the cost up front to have this thing be running full-time, just as many servers as the production environment? Did that ever come up and say, like somebody was like, why don't we just run 2 servers like your model? Mm-hmm. Did you have to have that discussion, and why did you choose to go with the more expensive, robust staging environment, and is that working out for you? Yeah,
that's a fair question too. One of the nice things about RightScale are that we can actually take our staging environment from literally being offline and costing us nothing, basically to up in a matter of maybe 20 minutes. Like there's not a hefty spin up time or cost with RightScale. That's a nice benefit of it. So we do leave our staging environment on as our developers need it, but we also have it capable of being completely spun down and disabled when it's not needed. And all of our environments work that way, so we don't have to eat costs when we don't want to. Sometimes we have people working around the clock, so they may need it, but if they don't need it, we are able to bring it up and down as needed. And for us, yeah, it's a piece of the business that we like to have. We like to know that we are going to have a replica, ready to go to test on. But yeah, it's a cost strategy and balancing costs.
So you shut it off?
We can shut it off if we need to, and we do frequently.
We never thought of that.
Yeah.
I think that's really what comes back to the flexibility, right? Do what works for your business, and if the idea is to try and save cost when and where you can, that's entirely possible. There are tools out there. RightScale is one of them. There are ways in which you can shut down or scale down appropriately for your workloads when you need them, whether that's production, whether that's deployment. Actually, maybe I'll just go off on a little bit of a tangent. So obviously you guys know RightScale uses RightScale. Our developers are notorious for launching stuff and then forgetting about them over the weekend. So we have actually built automation into our platform. We call it the Terminator script, which will go across our test environment and literally, if things are not in a locked state, we have this capability of locking environments in RightScale. If they're not locked, we'll terminate them. Our engineering management has set a rule, a discipline, that if you launch something and it's not locked, we can terminate it. And they do, and that helps us save costs. It's like shutting off the lights at night, right? Or for the weekend. So remember, the flexibility that can exist out there, that's kind of what cloud brings into your business. So be creative, apply ingenuity, think about what will work for your business and where your stress points are. The solutions are definitely out there.
Yeah.
I saw a deployment named Tokyo. Do you actually have instances running in Tokyo, and what are you using it for?
That's funny. It's just a geographical nickname. Like we have certain basically just code names. It's not related to a physical location, actually. Sorry.
So two-part question for me. First is around services used in AWS. I think you called out EC2 and S3. Do you use EBS or any of the other services they have? And then second question is around using something like Chaos Monkey or something to just run havoc on your app. Do you do something like that to just test how good your app is?
Yeah, that's a really good point. Yeah, we don't use necessarily all of Amazon services. We use a couple different ones. There's things that we look at incorporating in the future, like elastic load balancing, possibly RDS, but we don't use them today. In terms of just having like a Chaos Monkey kind of script, yeah, we have some certain tests we can run. We're not quite that sophisticated yet. That's a direction that we're moving towards. But yeah, knowing that if this service goes down, we want to know what's going to happen. We don't want to be waking up at 3 a.m. like, oh, we've never seen this happen. So I think for us, each piece that comes up in our infrastructure, there is an associated series of testing that goes on behind the scenes there. So we're pretty confident with any scenario that we've seen experience so far, we're able to actually recover from that. But in terms of having like real time on the fly, like, okay, this service went down, spin a new one up, we don't have anything automated like that yet. But I think it's, it's very valuable to do.
Great. Any other questions? Probably time for one more. If not, we'll leave you guys with time to get to your next session. Thank you very much for coming.
Thanks.